Hello and welcome to Teaching Python. This is episode 115, and today we're going to be talking about a program called DroneBlocks with Dennis Baldwin, its creator. My name's Sean Tiber. I'm a coder that teaches.
And my name's Kelly Schuster Paredes, and I'm a teacher that codes. I was sleeping, sorry. I'm still in daydream mode. I've got 2 days left, Sean.
What a great summer you've been having, right?
Yeah.
Well, excited to welcome Dennis Baldwin to the show today. Dennis, welcome, and we're excited to talk with you.
Thank you. I'm super excited to be here.
Well, we've got a lot of good stuff to get into about drones and how to program with them and how to, really use that as an exciting way to teach. Kelly, anything in particular that you'd like to share before we get to the wins of the week?
No, I'm going to be quiet and maybe think of something later at the end.
I thought there was something that you were just itching to get out. So, all right, we'll go on to the wins of the week. All right, Dennis, you're up first. Something great that's happened inside or outside of the classroom.
Okay, maybe I'll share two if that's okay. A personal one and then a technical. Personal, we just dropped my oldest off for her second year of college at University of Oklahoma. So a win in a sense for her, a loss for us at the house, right? And then my younger daughter just got her first job. She's 16. So we're excited to have our daughters go out into the world and hopefully do great things. The technical win of the week, it's still a bit of a struggle, but we've been doing a lot of work with, dare I say it, ChatGPT. I was very reluctant to, even mess around with it and experiment with it because people, get freaked out about AI. But from my experience, we got a long ways to go. But what we were doing was working with making DroneBlocks somewhat compatible, like the block coding. So essentially you would interface with a GPT prompt, tell it, hey, here are my blocks. I want to create a mission, like teach me the equation of a polygon in block coding. And so it would spit out a response after we trained it a little bit. And then all of a sudden you'd see these blocks on a canvas. So, it's really, I'll leave it with, people get scared that, hey, like maybe in the technical space that ChatGPT or AI is going to replace jobs. But I think from a fundamental standpoint, it's a good foundation. You can have it do some low level work, right? The work that you might struggle through a little bit, and you get to maybe add your secret sauce or deliver value on top of that. So ChatGPT has been interesting, and we hope to roll that out to our program in the near future.
That's super cool. And I think you probably just had a couple of code block instructors go, what? It can ChatGPT can code blocks too? Because I think that was like their workaround. Oh, we'll use EduBlocks and we'll just force them to do block coding, instead of it's kind of like the handwritten essay. So that's pretty cool. That's I from the past episodes, I've just been drinking the Kool-Aid of AI, trying to read everything and isolate the sensationalism. But it is an interesting platform, and it does open a lot of doors to creativity and that idea of what a kid can create when they're not limited by what they don't know. It's kind of like that JIT, that just-in-time learning. So that's pretty exciting. Exciting win.
Thank you.
Not as exciting as mine, but Sean will be proud of me.
All right, go ahead, Kelly.
So I'm in preparation for next week is our official start where I have to go into school. I did delete the 3 apps that were sucking out the time of my coding. Sean's like, yeah, just quit. And so I deleted them off my phone. So I'm no longer sitting there playing these mindless games that I do during the summer to just detox and get away. And so that was officially done today because I wanted to I picked my phone up and I needed to do some things. I started playing. I'm like, oh, it's gone. I'm deleting. Moving on. New school year, ready to go. So that was a huge win. Just say no.
Yeah, it's a proactive win, right? You're ahead of schedule by saying, I'm going to remove these things out of my life that are blocking my productivity or sucking away time.
I have no idea what I'm going to do this weekend. I'll actually have to talk to my family, I guess.
First time for everything, I guess.
Just kidding.
All right, so on my side, the win this week is that I'm away from home. I'm traveling this week back to the corporate mothership. As many of you know, I have several summer interns that are working with us in my day job at Mondelez, and they are presenting their final projects. So they're presenting to our entire organization all the work that they're doing. And it's really gratifying to see these final presentations. It's like vicariously through them, I get to feel that win. And I know that I remember it's been 20 years since I did my intern presentation, what it felt like to be done with that, to have that sense of accomplishment and feeling that you built something and did something really cool and interesting, and that other people appreciated that. And so it's really wonderful to see them present and to be able to share all of their wins with the organization and get that really warm feeling of recognition and support and appreciation. And I have to say, it's one of the things I love about my new job is just the community support within our technical function is really outstanding. And so it's been really great to ensure that those interns could feel that support and encouragement in the process. So it was a big win. We just walked out of the first half of that, and tomorrow we get to go back for another session with the remaining interns. So it's pretty exciting and fun to be able to see this from the front row.
Yeah. And the big win is you don't have to do grading after that.
Oh, no, there's still grading. It's just not letter grades.
That's the worst part of presentations, I think. And the learning's amazing. Watching people grow and giving feedback and positive and critical is great. But when you have to open up the grade book and put in the grades, it's not so much fun.
Well, it's funny how being a teacher has changed me. Before I was a teacher, when I would have to do something like this and give feedback and, critically assess how someone did in a way that helped them grow or helped us understand their capabilities and potentials, I used to kind of dread that because I didn't know how to do it, or I felt uncomfortable, or it was awkward. And now that I've been a teacher and I've done it literally thousands of times, it is so much more easier for me to do it. It's easier for me to get into that space where I can be thoughtful and fair and give good feedback. And so I'm really glad that I've been able to incorporate that experience into my professional corporate life as well.
Oh, that's so sweet. Always a teacher. Sorry. We have our moments, Dennis.
I love it.
And we are super excited to have you. When I saw what you do, I quickly said, Sean, our next guest is for you. So I'll segue there to Sean.
Yeah. So, Dennis, welcome to the show. Welcome to our conversation. We're excited to discuss all of this with you. I think you have done a lot of the things that I've only dreamed about doing. We talked about those ideas that you have that sometimes are limited by the things you don't know how to do. You've gone off and done it. And so, reading your bio is like, wow, that is so amazing that you've done that you've worked with those things. So let's start kind of at the beginning, I guess. You're the creator of DroneBlocks now, which is a block-based coding approach to programming drones with a lot more. I mean, it's a very simplified version of it. But let's talk a little bit about your kind of lifelong interest in RC cars, planes, and how that's turned into drones and coding and so much more.
Sure. Well, thank you for tapping into a bit of the background, because I think that's important and not a question I get asked very often. But yeah, so early years, middle school, probably got into RC cars and started messing around with planes. But then I had to do that thing called study and focus on what I wanted to be when I grew up. And so that led to studying engineering in college. I was an electrical engineer. I say was because I do very little electrical stuff anymore. It's all more software related, but the physical aspects of building drones, soldering, wiring, still is probably one of the more important things to me personally, right? It's just a good way to get away from the computer, get hands-on. And so that love of, I guess, RC led to, discovering kind of some of these open source projects, ArduPilot, PX4, and then in 2015, I guess, DJI released an SDK, and having been a software guy since I got out of college, I really saw the power of combining, something that I loved, which is the RC, remote control side of things, with my professional career of programming. And about, I guess, 2015, 2016, I was volunteering at a program here. A good friend of ours, she ran it at our elementary school it's called Tech Team. I'm outside of Austin in Dripping Springs. And so we started 3D printing drone frames, assembling them, soldering, the ESCs, hooking up the motors, flying them. And of course, kids were like, oh, this is cool, but, we want to put a camera on it. We want to take photos. We want to do all of this stuff. And that's when DJI, the Phantom was, as you guys know, the early day drone. And then they started releasing smarter hardware, right, with the ability to be programmable through the SDK. And so we put together this proof of concept that used a Phantom. And now I look back and kind of cringe. If you've seen, Phantoms are good size, but we also had an Inspire 1, which is a lot larger airframe. And we were using block coding to fly those around outdoors in a field, take photos, and really, it just, I'm not a educator by trade. I just love open source. I love community and sharing information. So, that led to like saying, okay, well, maybe there's the possibility of developing this app, making it more widely available. And so that's sort of how it all began, is just out of the classroom, creating the app, making it available, supporting people in the open source community, and really trying to support as much hardware as we possibly can.
Nice. I mean, I think like it's such a great, great progression as well, because you were there at every step along the way as we made that transition from, RC, where it was very manually controlled with a lot of great, electronic support over the years, into what became possible with drones, and even taking it to the next level. So I think what is interesting to me, or where I've been fascinated in drones, is that progression from, okay, so we have software assisted drone flying, right? Like the ability for a drone to hover is not because I'm an amazing pilot, it's because the software is really good, right?
Yes. Yeah.
But where we really get interested and where we get fascinating results is when we start applying code and thinking about algorithms and how we can program the drones to respond to different stimuli or to follow a plan or a pattern. And what I'm curious about is how that idea of teaching the plans or teaching the responsiveness, treating it more like a robot than an RC aircraft, was useful, or where it changed things when it came to the students in the elementary school. Was that something that they got excited about or they got into? How did that change for them in the learning process?
Yeah, that's a great question. So as part of that program, Marissa Vickery, who's a good friend and helped, get DroneBlocks off the ground, she was running this tech team. And obviously, as you guys know, sometimes you need to reach outside of maybe the classroom and get volunteers, get support. And I think around that time, you guys, I'm sure, are familiar with Hour of Code, was getting up and running. And, all of I love it, but it's in a browser, right? It's you're delivering content in a browser, you're moving stuff around on the screen. And so the physical aspect of being able to take code, and that's why we introduced a simulator a few years ago, is to see your code on a screen, how it behaves, and then deploy that to real hardware. So that's probably a long-winded way of answering your question, Sean. It was like the I don't know if instant gratification of what we do is pretty instant, but just seeing software, digital kind of ideas go to digital, and then actually being deployed to the physical world with a real drone is amazing. I would love to personally. I spend a lot of time. You mentioned RC and the airplanes, and now we have drones that hover, but there's this world in between of the vertical takeoff and landing aircraft. And so that to me personally gets really exciting. If we could, in the future, interface with not only drones that hover and fly around, but actually unmanned winged flight would be really cool. And so I think drones inherently are kind of a cool subject, a thing, drone racing league and FPV and all of that. And what I like to say is that I kind of make maybe a comparison a bit to NASCAR or F1, which are amazing things, but you have like these elite drivers, racing around a course, but you don't really see what goes behind the scenes, right? The engineering, the mechanical aspects, the software aspects. So really just trying to, reinforce not only software, but that software is going to run on a physical device that's going to do something in the real world is very powerful. And we see it when the light bulb goes off with students.
Thinking about that, one of the things that occurs to me as you're describing this is some work that we did with what were those called, Kelly? The little Wally-like drones or robots, the ones we used on the table, like Vector and
Cosmo.
Cosmo
And Vector.
So we could program these little robots that were relatively inexpensive, probably about the same size as a little Tello drone, like you can use with DroneBlocks. But there's something about seeing the code happening in real space that appealed to students, like that they could really get it and understand it in a fundamental way that was harder to do on a screen or on the web. It's that almost like we live in a three-dimensional space, right? We live in this world, and to be able to write code that makes something happen in that space where we live was much easier for them to just quickly understand and process when they could see it happening. They could touch it, they could stop it, they could, see that movement and motion. And it sounds like that's a lot of what you were experiencing with drones and DroneBlocks, was to be able to take those conceptual ideas, the theory, and turn it into real space movement, action, sound, stuff that they could see and understand really natively.
Absolutely. I'll just, as a side note, the number one thing or most exciting thing for kids is when they drag like the flip block out onto the canvas, right? You see the drone flip like on the screen, the simulator. And then, I was the same way. I was like, there's no way this is going to work. And Tello and a lot of other drones just do an amazing job of flipping and holding position. There's a lot going on there to keep that drone in the air, but for it to maintain position. It's very impressive.
I don't think people believe us. Like, you can actually make the drone do a somersault in midair. With 1 second it's hovering, and the next second it completely flips around and comes right back to hovering. And it's the most magical thing you can imagine.
It is.
I was just thinking of that while you were talking, both of you, because you were saying in a simulator, just this past year, some of my 8th grade boys, it's fun. They get the drones out. I put them out and I let them do sometimes the remote control, and, they have either their phone, and we have different types of drones. We have the Tellos, and we have also these really tinier ones. I don't remember the name of them. Sorry, I'll look it up later on the show notes. But, they play around with them and they're controlling them. And I said, that's great. You've been controlling them for about 2 weeks. Try to do what you just did in code. And we had no simulator. Amount of times, they didn't realize the height of the ceiling, and the flip was great when they finally got that code in, and the hovering. And it reminds me of the time when Sean first introduced the Tellos. I walked into the classroom and I almost got taken out by one of the students, and he caught the kid with a camera at the exact time. And it's like this photo that we love having. And he's like, it only takes me out. So in the simulator, is this it's part of the DroneBlocks as well? Is that a part of the product?
That's correct. We introduced it, unfortunately with COVID and everything, just to have a way to sort of carry forward some of the work that we were doing behind the scenes with the hardware. We knew that, and so yes, that around that time we have the simulation. It comes with the whole package. But I'll just go off on a bit of a tangent. One thing that I've seen, I used to do a lot of mobile software development where, you have a simulator or an emulator, iOS or Android, and you get to sort of see on the screen what happens before you deploy your code to real hardware, right? And so I would argue that it's probably just as important, or not, or even more important, to be able to see your code, so you're not, running a simulation so you don't fly into a wall, or maybe you're, telling it to land by descending altitude, but perhaps you have a block that's telling it to go up, right? So, being able to see that simulated before you deploy to real hardware is something that we stress the importance of, and it's what we also see in industry.
Yeah, it's Quate. You're not going to put the pilot out there flying the plane before they've
Right.
a couple of simulators.
That's a good point.
And I love that idea. They're not that costly of bots, but if you're on a public school budget, to break a drone is cringeworthy, right? So that kind of helps. It's not fun to just slam them up against the ceiling and pray that it didn't break. They are pretty durable, not gonna lie, but not too durable.
Well, the other thing that I think is important for the learning process, and I see this with professionally with writing code as well, is that the loop, or the time between when I make a change or when I write the code and when I can see it, see the effects of that, and then also when I can make a change to improve upon it or to correct some behavior, the shorter I can make that loop, the faster my learning occurs, right? So if you think about it, like I can, in the simulator, I can run at double speed, right? So I can like watch my program execute, and then if there's an issue, I can fix it quickly and then run it again. I don't have to wait for a drone to charge. I don't have to go find it from across the room or whatever. I can reset and get going again. And I think we saw that a lot with some of the work that we were doing with, autonomous driving cars and with robotic students, where they could simulate, check their results, and then make adjustments. It's that kind of engineering process loop that's really important, and simulation makes that happen much faster.
That's great to hear. I'm impressed that that's happening, at a younger age level. It took me a while to really understand the importance of testing code and simulating, because a lot of times you're like, oh, I want to see this work and I want to see it now, right? And Sean, to your point, if you can kind of speed up that loop to where you can simulate tests that get you out to the field, or in the air faster, even better.
So I want to ask, and this is a little sidebar on my nerdiness side, and actually Sean loves sensors too, but talk about this data sensor. I love this idea, the curriculum behind using the drones with like those science sensors and everything.
The data bot?
The data bots.
Right.
What are those?
An interesting hardware partner of ours, and they run this little, just really cheap board called the ESP32, but they've combined like 15, 16 different sensors in a little cube. And yeah, Kelly, just to be able, so the sensors are interesting, and I always struggle as, a software guy, like ideas, how do you use them, right? And so sitting on a table, I had this idea the other day, like hooking it to my washing machine, right? Because it has Wi-Fi, it has Bluetooth, like just to send me an email or a notification when the wash is done. We have a real problem in our house where, especially my daughters will leave their wash in once it's done, and I go to open it and I'm like, dang, it's my turn, right? So, all that to say, this device, all of a sudden, there's this, I guess, buzzword now, IoT, right? Internet of Things. You now have connectivity, you can get sensor data, put this thing on a tello, do stuff in real time. And so we have this whole machine learning course that we authored around DataBot, just to give people ideas of what's possible. But yeah, that is a really fun device, and we're looking at, more interesting ways of incorporating it into the curriculum.
Very cool. We can go out, just fly outside and check the different areas where there's grass or where there's concrete and see the heat index. It's just bringing that data science into play, and more like a real world connection. I was thinking the other day, I saw FPL with their drones out, and I just sat there, and my kids were like, "What are you doing?" And I said, "I'm watching the drones." And they're like, "What?" Yeah. And so what a great tie-in. I didn't have a question. I just saw it and I was like, wow, that's great. Sensors.
Well, I'll add that, at some point the drone, it's a obviously a flying computer, but it's a platform, right? The drone, why did DJI become so successful? Because they have amazing hardware, but the cameras are higher quality. You can take photos, you can create maps, you can do video. And so the drone is secondary. It's all about the data that you can acquire. So putting a data bot or some sort of sensing capability to hardware, and then, showing that, okay, well, in industry, less of the time might be spent flying the drone or programming the drone autonomously to fly and map an area, but it's more like, what do you do with the data on the ground? Like post-processing, right? Analyzing that data, seeing what interesting things you can learn from it.
Well, it's the tool, right? So I think that's one of the things that Sean and I like about the computer science curriculum and everything. It's the tool and what you're going to do with it. The segue from what you're going to do from learning about drones. Kids go in, start playing, great, but if they can automate this code in order to do a specific job that they might want to use in the future, maybe they are going to be a videographer. Is that correct? How do you where they use the drones? Yeah. Or they fly over a sports, and maybe they have a certain length of field. So all these possible curriculum ties that teachers can bring into the classroom to connect, give a student a scenario. Okay, you're going to be working for FPL. You're going to be filming Messi at interim, into Miami. Program your code so that you have to do this link, so that it tends to, the tool provides the curriculum support for your dream. So it's a fun aspect to have in a computer science classroom.
I think one of the questions I had is that I think drones force us to think differently, right? Like, you have to think in three-dimensional space, the fourth dimension of time. Where am I going? Where does this happen? It's different than even driving around a robot on a table, like we were doing with the Cosmo, because there I'm thinking about two-dimensional, space and where I'm going to move to. Drones require us to think differently, right, in order for them to work. But they also empower us to think differently. A helicopter pilot thinks the same way that a drone pilot does, right? Or a F-35 pilot thinks the same way as like a VTOL drone pilot would think. But the difference is, I don't have to go to school and be in the military with millions of dollars of training under my belt to fly a VTOL fighter jet, right? I have a VTOL drone I can use, or I can think differently. And the barrier to entry, the cost of entry, and the even the age of entry is different with these drones and with the capabilities here. But I also like the fact that that's combined with the computational thinking. So it's not just about thinking in space and time, it's also thinking about breaking down problems into smaller parts and how to solve those and how to integrate the solution back together. In your experience with DroneBlocks and the simulator, the real world, the work you've done with schools, is there like a way or a method that helps like unpack that for students, helps them realize or unlock that that's the way we need to think when we use drones? Is it something that happens gradually, or is it something that happens bang right at the beginning?
I'm glad you threw that gradually thing in there, Sean. I feel like that's for me, that's certainly how it happened, right? And I was not exposed to drones, until about, I guess, 15 years ago or what. I don't know if you guys remember the Parrot AR drone. It like came out in Brookstone, and it was like, wow, what is this thing, right? And it had all these capabilities, a camera. But yeah, so for me, I sort of my I guess learning style that I try to convey through some of our curriculum, and I'm not the only person writing curriculum, is expose users to as much as possible, right? Like I was thinking, okay, I'm gonna get on this podcast with Sean and Kelly, and they're gonna like quiz me on my Python knowledge, right? And I realized, I touched Python a lot in the early days, but then I started to realize, as I mentioned, ChatGPT, it's more like, learning, having a process of understanding like how you program, right? You learn like the fundamentals, variables, strings, Booleans, all this stuff about programming that can be incorporated or taken to any language, right? The tool, as Kelly said, it becomes a tool, right? And so, Sean, I think that like exposing them to languages, exposing them to general topics like machine learning with DataBot, well, then all of a sudden, I think prep students to maybe take an interest in something and then go into the real world and say, hey, maybe I want to pursue a career in data science because, I did something with a little sensor device called DataBot, or, I was using block coding to have this drone kind of repeat this mission. Maybe I'll take an interest at working at an aviation company doing QA, right? To be able to repeat, that's one thing that we see a lot of people do is create repeatable code. I'll share a story with DJI. They reached out to us a few years ago, and their QA team was working on a new drone, and they were using DroneBlocks because they wanted to see the performance of their drone outdoor, right? So to see it go to each location, make sure that the GPS accuracy and everything was there. But I guess a long-winded way of answering your question, Sean, that I think exposing them to as many languages as possible, exposing them to hardware, and really kind of opening the door to a different way of thinking to where they can kind of maybe become more of a generalist and then kind of hone in on more of a specialized field of study.
And I think you hit that for me in the middle school, and even venturing into high school, that generalist idea of introducing them to languages, introducing them to the skills that are transferable is like yours being a teacher's primary goal. And I was sitting there thinking, for any teacher that's probably going, well, how am I going to get drones, or how am I going to get this approved? This is critical thinking. This is algorithmic, algorithmic thinking. This is spatial awareness. You can't even imagine the sixth graders that grab this thing and can't really fathom the room that's around them and their drone and how they're drawing or flying. You want to add any other skills that you guys have talked about through your curriculum?
Yeah, so I think we do where I spend oh gosh, I jump around from different languages, JavaScript. Now we have Node, which is server side. There's Node-RED, which is almost like a flow-based programming. You could think it's maybe, we'll call it visual, right? It's very similar to Blockly, where you can embed logic into each of the blocks. So Python, JavaScript, Node-RED. We just released probably earlier this year a JavaScript library for the Go One. It's this quadruped robot, and it really just allows people to. What I try to reinforce is there's the languages, and I think languages are important. I don't think that anybody should say, hey, this is the one language, but it's then understanding how you get access to that code. There's a lot of open source code out there. You fork it, you set up your environment, boom, you're up and running. So, that's more of the technical side of things, right? And then we want to really kind of evolve towards, we're working on this new hardware. It's PX4 based, where you're learning a little bit more what goes on beneath the hood, because I feel like we claim we're in the STEM field, right? But a lot of what we focus on is computer science, and I think there's a part of that we're missing. It's assembling, and like I talked about earlier, like soldering. Soldering might be going a little bit far. Where I'd love to have a conversation with you guys in the future. Like, is soldering in the classroom crazy?
Yes, we love soldering. That was one of the skills that Sean brought in, and it is.
Oh, that's amazing to hear.
He loves everything hardware.
I want to send you guys a kit then, and just, it's very early stage, but the point is assembling, configuring, learning how things work, right? And then you're in the world of, okay, now I can program it, but I also understand some of the fundamentals. So I know that was long-winded, but aside from the software aspects, is really kind of getting under the hood and teaching some of the physical aspects of the hardware.
Well, that just really got me excited because I was going to ask you about the Go one, but I'm going to go. We can go back to that later. The soldering of the drones, for me, that's like the full picture. If you can sort of imagine the kids playing with the Legos or the Spike Prime. Even to this day, I put a box of Legos with a robot, and the kids are going to spend more time creating what's going to go on that bot and the gadgets that's going to take out the next bot or the sensors, and they'll spend 85% of the time building the bot and 15% of the time coding sometimes. And you have to remind them, it's about the movement. But there's something that happens when kids can get their hands on that hardware. Even the soldering of a little ladybug that lights up a couple lights and it has some resistors. That's always said from the kids. That's my best class. That's my favorite class, is that soldering class. So you hit the nail right on the top, because it's a big component for kids to say, I made this and now I'm coding it. So kudos to you on that. I didn't know about that. Sean, you want to add?
No, I was just going to say, soldering is a huge win, right? And it was a surprising, I thought it would be good, but it ended up being, to Kelly's point, a lot of kids' favorite activities. And a lot of them got into this Zen state of just, I'm soldering, I'm focused, I'm tuning out the rest of the world, and I'm doing this. And I think for a lot of students, that also built a sense of confidence that if they can do something like that, that's intimidating at first, right? Holding a 700-degree soldering iron and, and melting metal together and like making these joints and all, like, it's just, they just got this sense of satisfaction out of it that, like, if I can do that, there's other things that I can do too. Like, I don't have to be scared by these things. And I love the idea of going into drones as a next step, because now it's something that they can take to the next level and say, I made this thing and now it's flying, right? That's a huge win, and just a big confidence booster for our students to be able to have that sense of accomplishment and the sense of a real accomplishment, not just something that was, oh, I followed some instructions and it was a kid. It was real challenging work, and they did it.
Well, I have to say thank you guys for a bit of the enlightenment here, because I think one of our success criteria that we've been trying, the bar that we've set for the kid is like no soldering, right? And maybe there's a solder version, maybe there's a solderless version. But for me personally, Sean, I like the way you said it. For me, soldering is a bit of therapy, right? It's just, I get to go over here, I get to tune my iron, I get to melt metal together. It's a beautiful thing. I enjoy it.
Very cool.
I wanted to switch gears a little bit. Go ahead, Kelly. Go ahead.
No, you can switch. I'll let you switch. I always am the one that switches.
Okay, well, it wouldn't be a talk about drones if we didn't talk about hardware and like what people should be looking at. And this is very selfishly for me too, because my drone, and one that I've gotten so much joy out of using and so much utility out of using, is a DJI Mavic Pro, like first generation, came out 5 or 6 years ago. Phenomenal drone, right? And if I were to upgrade it to the latest Mavic Pro, it's even more incredible. But I wanted to ask for recommendations to get started with, both drones that are compatible with DroneBlocks that work really well for teaching different things, as well as what may be good for professional development or personal professional development around building drones, understanding how they work. And we can kind of divide it up into, airborne drones versus robots. But let's just start with, if I'm a teacher and I want to get some drones that will work with DroneBlocks, maybe 5 or 6 of them just to get going in the classroom, is the Tello the best place to start? Are there other drones out there? Where should people be making their wish lists for hardware?
When I get asked this question, Sean, I was kind of like, I hope Sean or Kelly don't ask this question, but it's been asked, because I don't want to sound like a DJI fanboy, but DJI makes the best hardware out there, right? And so the Tello, and maybe we could draw a distinction, I don't know if this helps, is indoor versus outdoor, right? Because there were days when we were flying Phantoms indoors, and I think we didn't know any better, right? But Tello for indoor precision flight, programmable flight is is certainly the best out there. And there are different models, as you guys probably are aware. There's Tello, Tello EDU, and then Tello Talent. And so standard Tello, you know, you can get at Walmart. It's very programmable with DroneBlocks. The Tello EDU has a little bit more capabilities with mission pads, where it can, all the drones will hold position, but the mission pads can actually sort of relocate, drone can relocate to localize on a certain pad, pad number 3 or pad number 6, so you can sort of navigate around more maybe similarly to like how you would navigate outdoors with GPS. And then the Tello Talent has the little add-on ESP32 sensor. So that's the indoor stuff. Now, getting back to your question, Sean, of like, if you're going outdoors, obviously Mavic Minis, you know, are incredible. They're tiny, they're relatively safe. They have great cameras on them. We unfortunately were not able to support the Mavic Mini. Years ago, it was announced, and we don't have full access to GPS interface, like the SDK. And so you sort of, there's some challenges there, right? Like the Mavic Pro, you can just, you know, tell it to go wherever, and the GPS waypoints are followed. I don't know. We've had many conversations with DJI about the Mavic Mini, but so outdoors, currently where we stand, we haven't put a lot of focus on that. When Tello was released, we said, okay, we want to focus on in classroom curriculum, hardware, and then we want to see where we can go from there. And so that's where this new drone, which is PX4 based. PX4 is this autopilot, open source, incredible community behind it. ArduPilot is another, where now you'll be able to build, configure. We've worked hard to get position hold indoors. It uses a couple of sensors, a rangefinder, and then optical flow for it to be able to hold position and be programmable. That then can be taken outdoors to do very similar things by adding a GPS to it, right? A lightweight, cheap GPS unit. So that's more of the, I'll call it kit DIY, you build it yourself. But for, you know, outdoor, like if we have these conversations every week, what outdoor hardware can we support? And, you know, the only thing that we keep coming back to is like maybe Skydio. Skydio is like probably one of the better consumer, prosumer drones, but we haven't really gotten full access to their SDK. So long-winded way of saying that we haven't cracked the outdoor drone nut just yet.
Well, that's okay. There's plenty you can do indoors, right? Like,
yeah, exactly.
and it's much easier to control the temperature and weather too. So
yes. And the other challenge is we partnered with a group to do Part 107 curriculum. As you know, there's all the regulations of outdoor flight and what happens if you're in, you know, airspace and all of that. So we just, you know, it benefited us to focus on indoors, have simulation, and then that's the starting place, and we'll grow from there. And obviously watch what the regulations do over time.
Yeah, and just to add some teachers are thinking, they're looking at the price. The Tello is about what, $140 or something from Amazon.
Right.
And you don't have to have a class set. We don't have a class set at Pinecrest. We have, I think, 4 or 5, and you share out, you code, you test. And with the simulation, I'm assuming everyone has to make a simulated flight that actually works before you can put it onto a drone itself. So that's like a tidbit for teachers just to kind of think about, maybe 1 or 2 if you can get the budget. And then the other thing, just from experience with the little kids, we have these nets that are built so it kind of stays in a certain area of the room and safer, and safety goggles is always a good thing to get around and to make sure you have on so that your division heads don't get mad at you. I'm not that it hurts them, but you never know.
That's actually very smart, Kelly. We about 3 years ago partnered with Bell. You know, it used to be Bell Helicopter, now it's Bell Flight, and they have a annual competition called AVR, the aerial vertical robotics. They changed the name, but and we've supported them through documentation, helping with the build. But it's a larger drone, right? It's a competition where you're navigating around, putting out simulated fires, and the whole competition is done within a netted area, because these things have like 9-10-inch propellers on them. So I'm always an advocate of safety. Don't always follow it maybe in the lab or in the garage, but certainly in an environment where students are around, we do.
Absolutely.
Yeah, and I think that's a really good point. Things happen fast with drones, and it's,
right.
it's something that you want to make sure that you are thinking of before it happens. So definitely a good call out to think about safety and how to plan for that as part of your curriculum as well.
And they sometimes fall behind the projector whiteboards that you have. So make sure you don't fly around there, because getting one stuck in there is never fun. Especially
yeah, but it's
if
also kind of like finding quarters in the couch, right? Like if you find a drone later, you're like, ooh, exciting.
like, stop running it. No, a lot of fun. A lot of fun to be had with drones. Real quick, the robot dog, because it's so cute. And some people would say it's not really cute, but what is that part of DroneBlocks? What is the robot dog?
So yeah, I mean, I guess like I said, part of me, if you've been in the industry for a long time, you kind of, I think I'm generally, I'm an optimist when it comes to software and what's going on there. And then I can be a bit of a pessimist when it comes to like hardware. And, you can imagine all the bad things that people can dream up to do with drones or with robot dogs, the quadruped. But we have a great relationship with Unitree, and one of our partners has, imports them, and we work together to sort of bring DroneBlocks compatibility to Go One, right? And then, being able to, because I would love for us to sort of identify maybe the best of breed for each kind of hardware platform, and then for DroneBlocks to support it. So right now, indoor drone flight, it's Tello, it will be PX4, and then now we support the Go One quadruped. And so that's the DroneBlocks support. But then, as I mentioned earlier, we released this JavaScript library that allows you to do autonomous control, right? And so the dog, obviously the mechanics of how this thing walks and navigates is absolutely incredible. And for your listeners that might not be familiar with it, I'm sure you may be familiar with the Boston Dynamics robots, the Spot, right?
Yep.
And those are much bigger. The Go One is smaller in size. It's still, I think, about 25 pounds, if I recall. But we saw it as a way to create another opportunity to engage, students in a classroom, right? To learn programming, but to see, the output, right? Of taking their code, whether it's Python, the block programming, JavaScript, and being able to navigate around. And we're getting close to releasing a course that shows how to do color detection, like computer vision stuff, with the hardware. So we saw it as a opportunity to create more engaging content, not to be done in a we're not trying to advocate anything dangerous or malicious, right? It's just a platform where we see kind of the robotics industry heading.
Very cool. Yeah, I first saw it and I was like, oh, that looks like Spot, just not yellow.
Right.
I asked for a Spot, but they said no.
I mean, the last we heard, they're 75,000, I think, something along those lines. So
yeah, I got a laugh, and I was like, but it's so cool.
Yeah.
I do exploratory robots, and for me, the drones are a hit. Anything that's robotic is considered an exploratory robot for me. So I'm always about buying the one-off bots and exploring them.
Yeah,
so.
That's cool. We've had a handful of schools purchase them and like dress them up with, wrap them or whatever and make them like a school mascot, right? So I love, working with teachers because they're so creative, they're so resourceful, right? And if, they get a grant or an opportunity to purchase something, the stuff that we see people do is really cool.
That's it. I'm going to make a panther out of the quadruped. Sorry.
We need a grant for teaching Python. Right?
Yeah, exactly. We need a grant ourselves. Maybe they'll give that to
mascot
us.
of Teaching Python.
Very cool.
Nice.
Well,
I know we're running a little bit short of time, but I wanted to just give a chance, Dennis, for you to share the best way to get in touch with you, to learn more about DroneBlocks. You know, if people want to learn more, if they're intrigued by this, and how could you not be intrigued by this this topic? Where do they get started? How do they connect with you?
So you're more than welcome to email me personally. It's just DB, Dennis Baldwin, letter D, letter B at DroneBlocks.io. We also have support at DroneBlocks.io if you have a more generic question. And then I always advocate, because I'm a supporter of community. I love to give back because I've gotten so much from online forums. We have a forum at community.droneblocks.io.
Very cool.
Excellent.
Well, I will definitely be hanging out there a little bit more often. I'm already looking at the Tello talent. I think it's got a lot of cool stuff that we could do with it and have some fun with it. I think go ahead, Kelly.
I said I see this as on our Christmas wish list. You know, Sean, we put a wish list out, and I can see Sean's already like, this is what I'm buying.
Yeah, I'm not waiting till December. I mean,
please put a PX4 drone kit on your wish list, Sean, so we can, get some more beta testers.
Absolutely. I will fire up the soldering iron and we'll make it happen. All right. So I guess that pretty much does it for this week. We're going to wrap up here. Dennis, thank you for sharing all this great information with us and getting us to dream. I think it's, it's funny. I think they always put it on every documentary about the Wright brothers, about, flying, that, as humans, we've always dreamed of flight, right? Like this is something we think about, we dream about. And one of the things I love about drones is that it makes flight more accessible to more people. It makes it something that a kid can do. It makes it something that someone who may not be able to fly for physical limitations can have a drone and even be present, through FPV, to be able to see what it would feel like to fly like a bird. So what you're doing with DroneBlocks and what you're doing to empower and enable people to think about flight and to transport themselves in a new, different way, and to think differently in a new, different way, is really powerful and really compelling. And so just thank you for sharing that with us and helping us dream for a little bit during the show today. For me, it meant a lot. I know Kelly's smiling over there because it means a lot to her too.
Absolutely.
Well, I just genuinely appreciate the good words, and I thank you for having me on.
Our pleasure.
Right. It's our pleasure, and we'll definitely have you back to talk more about drones in the future. I think for us, we have a whole lineup of guests coming over the next few weeks. Kelly's been hard at work lining up a really great lineup to talk about a variety of topics. So for our listeners, stay tuned. If you enjoyed this episode, there's plenty more coming. We'd ask as a favor, we put a lot of time and effort into this show, and we love doing it because it means we get to talk to great people like Dennis. Help spread the word. Help share this podcast or this episode with someone else. Leave a review for us on your podcast player of choice, whether that's iTunes or Spotify or Google Podcasts. Wherever you're listening to this, leave us a review and help us out by sharing the word. If you have feedback for us, things that we can do, or ideas for how we can add more to our show, please share this with us through our website at teachingpython.fm or through Twitter at teachingpython. We're always excited to hear from our guests and hear ideas and opportunities. It really has become a community around teaching coding and computer science, and we're grateful for each of you for listening to us and sharing with us. Kelly, is there anything I'm forgetting in terms of upcoming episodes, guides, new stuff on the way that people should be looking out for?
No, not so much. I just wanted to say that if you have a suggestion for a guest, also email us. We got Dennis, thank you, who sent that to me. I forgot to pull that one up, but yes, they said you have to have Dennis on. He's amazing, doing a lot of great things with drones. So if you know someone else like that, just shoot us an email and we will do our best to get in contact with them.
All right. Well, one more time, thank you again, Dennis, for joining us. It's been a pleasure to have you. We'll wrap up here for the podcast. This has been episode 115. So for Teaching Python, I am Sean, or this is Sean. Sorry, I'm like out of practice. I'm trying something new and it didn't work. So for Teaching Python, this is Sean.
I'm like, I am Groot. And this is Kelly signing off. Let me try that again. We'll make that better one. So we do for the recording. Go for it, Sean.
Yeah. All right. So for Teaching Python, this is Sean.
And this is Kelly signing off.